Hi, welcome to Vision classes. It's classes for IGCSE, GCSE, AS and A Level student. So today we have to discuss the coordinate geometry, all the concepts, fine. And then we will discuss some past year paper questions as well. Okay. So our free video lessons of IGCSE Math are available on our website VisionIGCSE.com. So you can check out for all the videos, free lessons, fine, on each and every other topic. We'll start here with the basic. Let's say, for example, if we take any point A and B, A is, let's say, x1 y1 and B is x2 y2. So we have a firstly distance formula. Distance formula is, let's say, AB here is square root of x2 minus x1 bracket square plus y2 minus y1 bracket square. So this is actually application of Pythagoras theorem. Here we have if we take, let's say, this point, fine, here this is x2, right, and this one is x1, and here y1, and this one is y2, right? So this whole thing is y2 minus y1, and this whole part is x2 minus x1, fine. So that gives the basically distance, this distance and this distance. We can utilize the Pythagoras theorem to calculate the AB, fine. So that's a distance formula, got it? So then nextly we have a midpoint formula. Midpoint formula is basically just so let's say we have here m is the midpoint, all right, and the m we can calculate using x1 plus x2 divided by 2 comma y1 plus y2 divided by 2. Done, that's it. So that's a midpoint formula. Then gradient is y2 minus y1 upon x2 minus x1. Gradient is, let's say, m here is equal to y2 minus y1 upon x2 minus x1. This is gradient form, all right. And then equation, we can use this gradient to find the equation of line. Y is equal to mx plus c, fine, and m is the gradient, this m, and c is basically y-intercept, fine, y-intercept, got it? And the y-intercept, suppose, let's say we have this is equation which passes through the 2, so 2 will be the here y-intercept, getting it? And we can calculate the gradient using y2 minus y1 upon x2 minus x1, all right. Then suppose, let's say, here you have lines are parallel, like this, lines are parallel, then here m1 and m2 are the gradient. For parallel lines, m1 is equal to m2, that's it. Then for perpendicular line, you have if let's say the line is perpendicular, this one, right? So m1, let's say this is m3, fine, m1 times m3 is equal to -1. These two lines are perpendicular, means this gradient, this line gradient are multiplication, their multiplication is -1. We'll discuss with the examples, all right. So here first one, even here in this case just a little bit of involvement of vector part is there. We'll take it in short, fine. So we have here P point is 1,7, Q is 5, -5, fine, and we have to find out firstly PQ, P to Q. Now P to Q means we have to take the Q minus P, fine. Q is 5 minus 1 and 7. So 5 minus 1 is just a 4, all right, and then minus 5 minus 7 is minus 12. So PQ is basically 4 minus 12. That's it. That's the answer, fine. Then nextly we have to find out the distance of OP and distance of OQ. So this distance we have to find out. So we have to use the distance formula. What's the distance formula we have? Square root of x2 minus x1 of bracket square plus y2 minus y1 bracket square. That's the formula we have to utilize. So for OP distance, so square root of, let's say O is here 0, 0. So 1 minus 0 bracket square plus 7 minus 0 bracket square is equal to 1 square plus 49 is root of 50. Similarly, we will calculate the OQ as well. So square root of 5 minus 0 bracket square plus minus 5 minus 0 bracket square, which will be equal to again root of 50. So it means OP is equal to OQ. We can say that. And yeah, that's it. Fine. Then next point chord is here. PQ is the chord of a circle with center O. Means actually circle passes through the this two PQ. Fine. P and Q. Alright. So yes, PQ is the chord of a circle with center O. Fine. So chord is basically the line that connects the any 2 points on the circle. Fine. Calculate the circumference of the circle. So to calculate the circumference of the circle, we have a formula 2 pi r, right? And here they are saying that center is basically O. Fine. We know that this is OQ, OP and OQ are the radius, isn't it? So radius we already calculated. OP is equal to root of 50. Fine. And that is equal to r. So you can substitute here 2 pi r is root of 50. Fine. And you can keep as it is this one. So you can write as a root of 50 simplified form 25 times 2, which is 5 root 2, right? So 2 pi times 5 root 2, which is 10 pi root 2 will be the answer in the simplified form. That's it. Then PQ is the diameter of a circle with center at R. Now they are saying that circle having diameter, this is the diameter PQ. Fine. PQ is diameter. Then you can think that the center lies exactly middle somewhere here R, isn't it? So to calculate R, we have to use midpoint formula. What's the midpoint? X1 plus X2 divided by 2, comma Y1 plus Y2 divided by 2. So here X1 is basically 1 plus 5 divided by 2, comma 7 plus minus 5 upon 2. Fine. So we will get the 1 plus 5, 6. 6 divided by 2 is 3. And here 1. 3 and 1 will be the center of the circle or coordinate of a R. 3, comma 1. Fine. Here the fifth question. Find the equation of perpendicular bisector of PQ. So we already calculated here the radius R, coordinate of a R. But here we have to calculate perpendicular bisector. Bisector means it divide into two parts. Fine. And we have to find out the gradient of firstly PQ. Fine. Then I will name the perpendicular line as a L, M. L and M. R already we know 1, comma 3. So perpendicular line gradient will be gradient of LM is equal to negative 1 upon gradient of PQ. Fine. So we will calculate firstly gradient of PQ 1, comma 7P and Q is 5, comma negative 5, isn't it? Now Y2 minus Y1. This is Y2 minus Y1 is 7. So minus 5 minus 7 divided by X2 minus this is X2 minus X1, right? So 5 minus 1, which is negative 12 upon 4 means negative 3. Fine. So substitute here negative 1 upon negative 3 means it's a 1 upon 3 will be the gradient of LM. Now the gradient, the line actually LM passes through the R. So firstly we can substitute in this equation y is equal to mx plus c. So y is equal to 1 upon 3x plus c, and we can calculate value of c by substituting R. Transfer this 1 upon 3 to the left. R point is basically here 3, comma 1, not a 1, comma 3, 3, comma 1. Fine. So substitute it clearly here. It's a y is 1, which is equal to 1 by 3 times 3 plus c. So 3 get cancelled out. It's a 1. So 1 minus 1 is equal to c. C is equal to 0 means we will get the equation as y is equal to just a 1 upon 3. X is the equation of LM. Fine. I hope you are getting it all these things step by step. Fine. Then next one is division of any line in the form of ratios. Okay. So suppose let's say this is the AB line, right? And this is divided in the form of ratio m is to n. Fine. And here A is x1 y1 and B is x2 y2. Fine. So to calculate this point, let's say x, we can use x. It's a x value n x1 plus m x2 upon m plus n. This is x coordinate of a x. Fine. And then y coordinate will be n y1 plus m y2 upon m plus n. Fine. Then we have same thing we have to apply here. So they have said that the A point in this case is A, just a A. Fine. And B point is just a B. And mn. Am is actually 2 and 3 here. Fine. So firstly we have to take the a times 3. So 3a and 2 times b plus 2b upon 3 plus 2. That's it. That's a m point. Fine. And simplified form is 3a plus 2b upon 5. That's a simplified form of answer. Getting it? So this is means just a division of any line in the ratio. Okay. I hope you understood this part in bit by bit. Okay. If you haven't understood, go through it again. And I have uploaded all these videos on our YouTube channel, on our website. Actually, all these videos are listed one after another, so you can watch there as well. Enjoy the math. Thank you.